This is the examples video for the lesson on solving quadratic equations by factoring. For number 1, we have to solve that x plus 6 times x minus 1 is equal to 0. As we learned in the lesson, in order for this expression to be equal to 0, this must be equal to 0 or this must be equal to 0. Either of them could be true. So if that is equal to 0, and this is equal to 0, that tells me that x could be negative 6 and x could be 1. So my solution is that x could be negative 6 or it could be 1. Those are the solutions to the original equation. For number 2, here's another quadratic equation that I have to solve. So the first thing I'm going to do is, to make this look a little more familiar, I'll move that 1 over. I'll add a 1 to both sides, so I get it over here, and I can say this is equal to 0. Now again, this isn't something I'm used to. I'm used to not having anything being multiplied by the x squared term. So I'm just going to divide everything by 2. So that'll leave me with x squared minus 3 halves x plus 1 half is equal to 0. This could also be thought of using decimals. You may quickly notice that 0.5 is really just 1 times 0.5. And if you add up 1 and 0.5, you get 1.5. So, according to what we learned in the lesson video, I can rewrite this quadratic equation as x minus 1 times x minus 0.5 is equal to 0. And this easily illustrates the solutions. X could be 0.5 or it could be 1. And remember, that again could still be expressed as a fractional 1 half. Now I have another quadratic, and similarly I'm going to move that 3 over to this side. So there we have it. And now 3, again, is really just like 1 times 3. But 1 plus 3 is 4. And I need a negative 4 here. So let's try this over a little bit. What if I had negative 1 times negative 3? Because that still gives me a positive 3. Well, if I add these together, I get a negative 4, which works with my formula, because this should be a minus negative 4r. So I can express this quadratic equation as r minus negative 1, r minus negative 3 is equal to 0. And this could also be written r plus 1, r plus 3 is equal to 0. But really, we've already found the solutions up here. The solutions are, not for x, but for r, negative 1 and negative 3. For number 4, we have a bit of a different problem. I have to find a quadratic equation with roots 3 plus I and 3 minus I. Well, if we look back to what we learned in the lessons video, I'm going to put some parentheses and set it equal to 0. If I have roots 3 plus I and 3 minus I, then that means x minus 3 plus I could go here. And over here I have x minus 3 minus I. Because with any roots I can write it like this, as was shown in the lesson. So now I can use FOIL. If I use FOIL and I multiply the first terms, I get x squared. Then I have to multiply the outer terms, which is minus 3 minus I and a positive x. And then there are the inner terms, which is a minus 3 plus I and an x. And finally, for the last term, I multiply this and that. So now I've expanded it into this big expression, and that has to equal 0. So now I can distribute everything, multiplied by x here, here, and I can do FOIL here. And let's see where that gets me. So now I have it all expanded out, and that is equal to 0. But some things cancel. So here I have a plus ix, here I have a minus ix. Here I have a plus 3i and a minus 3i. Also remember, I squared is equal to negative 1. So I can go ahead and plug that in. And I can also put these two terms together. So I've reduced it all the way down to this. And now minus a negative 1 is really just plus 1. So this, which is equal to 0, is my quadratic equation. As exhausting as all the calculation may have been, we finally come to the conclusion here. It's also important to note that even though I had complex numbers, up here I had complex roots. That doesn't necessarily mean that my original quadratic equation had anything complex. You might be able to contribute this to the fact that no factors of 10 can add up to 6. But in a few lessons, we'll be learning a lot more about complex roots.